Good morning, everybody, and welcome to IGTV. We've got with us this morning Mark Capers. And Mark, you're going to be talking about understanding security requirements, getting documenting and good documentation and good requirements from business drivers and policy. Wow, you took on a big one this week, huh?
Yeah, I'm going to try to compress it down into its core essence. But again, this is kind of married up to the one I did last week on metrics. And the idea here is to go back to the basics and say, everything we do around security is, what drives us is understanding good requirements. If you don't have good requirements, you're kind of floundering. So I just wanted to talk about some of that.
Yeah, well, go ahead, Mark. Take it away, and thanks again.
No worries. So this morning on Insights, I want to talk about why understanding requirements is important. And again, going back into what we do as security practitioners, especially dealing with IT systems, is the things that drive the design, the development, and the deployment and operation of IT systems is requirements. And when you think down to how security policies boil down into actual controls, the controls actually reflect either an amalgamation of different requirements into a single control, or in some cases they can just reflect a single requirement. So to achieve real and desired results, whether you're looking at the strategic level of your organization, a tactical issue you're dealing with, or at the project level, the requirements are your goals and they have to be properly understood. To generate good requirements, you have to have an understanding of what the actual facts are that you're dealing with, what the scope of what you're dealing with is, and the context. They're all critical. And they heavily rely on a good understanding of the systems in question, the confidentiality, integrity, and availability requirements. Those are all three parameters that you need to measure against, and how the system is used to achieve the organization's goals. So the requirements are actually the means by which decisions that you make on design, implementation, and execution of your policy and your projects, and how that translates into your security infrastructure carried out, and in some cases measured. This gets a little bit into the weeds, but like using the SMART system, there's a set of parameters around what makes for good requirements. If you look on either the CMM, if you're familiar with the capability maturity model, or if you go actually out to Wikipedia and look up these, look up engineering requirements, they'll have this list, but I'll quickly run through them. So if you're dealing with getting a good requirement, what makes a good requirement, you've got basically the requirement has a unitary facet. It addresses one and only one thing. It is complete in that it is fully stated, no missing information. You have to have consistency in your requirements so that you got to make sure that as you build a set of requirements for a particular project or an issue, that the requirements don't contradict any other requirements and they're fully consistent with your documentation and other processes and policies. Good requirements tend to be atomic, or what's called non-conjugated, and that means that a good requirement deals with only one specific element of something. So if you have something that says, the alert must have the IP and the MAC address and this, actually you should break that down into say the requirement must have the IP address. Requirement 2 must have the MAC address. Again, with that, you want to introduce some traceability, and so that the requirement meets all or part of a business need that you get either from a policy or a stakeholder. And you need to trace that back to those things and circle back after you've done things and make sure that that requirement is still being met and that requirement is still reflective of what those other drivers were. So that's part of also making things traceable and current, and make sure that they're feasible. A requirement can be implemented. Make sure that you can actually implement these requirements. If you're saying that your requirement is going to fix all security, that's probably a great goal, but it's strategic and it's not necessarily doable. Make sure that the requirements are unambiguous. So make sure that you concisely state whatever, without any sort of, way to misinterpret what you're trying to say. Try to make sure you spell out your technical jargon, define your acronyms. Somewhere in the requirements document, glossaries and indexes are good. Avoid vague subjects, avoid things that allow you to interpret things one way or another. You want to make sure that if you've gathered some stakeholder information that you drive down to that essence to what you're trying to do. Make sure that requirements are mandatory. They represent a defined characteristic, or they're actually a control. And controls, if we look back at our policy standards and procedures, controls are mandatory. So your requirements ought to be mandatory. And make sure they're verifiable. Make sure you can, after you carry out what you're doing and you're implementing what you're implementing, you can verify that your requirement is either met or not met, and this drives you back into the metrics. Often requirements kind of turn into back-end metrics so that you can either inspect, demonstrate, do some analysis or testing to determine that your requirements are being met. Now, when you look at building these requirements, all the sources that we have to cope with to build requirements, you've got business and security policies, you've got business models and business plans. Data models are really key in understanding when you start driving down to those low level requirements and the details, how to get your data elements, how to get your methods of transport for that data. And that's where you start understanding, where your regulatory impacts are and your confidentiality, integrity, and availability issues are. Your information architecture, your business process and system documentation all tend to be sources of where you can sort of sift through and get some requirements. The big heavy lifting with a lot of projects and a lot of strategy is going to be stakeholder interviews. And we'll cover a little bit more of that in a minute. You also want to use your industry knowledge about whatever vertical or specific industry or organization you're in, as well as using resources from SANS, NIST, other multi-industry or cross-platform knowledges. And you've got other solution criteria as well that are going to drive you into certain requirements. If you have contracts or service level agreements, as we've talked about, legal and regulatory are big drivers for requirements. You may have system constraints or other operational business organizational constraints and limitations. You've got strategic goals and you've got solution objectives. So as you move on into requirements gathering techniques, and this is certainly something that I've seen over and over and over, as you inherit a project or something starts up, if you think you know the answer, you probably don't. So this is why we get back into stakeholder interviews. It's very, very important to validate what you think you know. And that goes for whether you're responding to an incident, implementing a project, or just even trying to validate that you understand your organization's mission. So with a lot of problems, make sure you do a good root cause analysis. If you're designing a system or trying to put in a system to solve an infrastructure problem, make sure that you do cause and effect. Fishbone diagrams are a great thing to drive out solutions. And again, they drive out solution criteria. So understand what your causes and effects are for a particular issue or problem. Make sure that you understand and prioritize your problems and solutions. Certain solutions will fix some things and may break others, and you need to prioritize what you're fixing and you're breaking. Hopefully you can drive through all that and fix most of it and not break too much that you didn't need in the first place. Make sure you understand your scope, have it well defined. And make sure you discriminate between events and responses. Understand what's a system event, understand what the responses to a particular set of events are, and that may drive some requirements about putting those controls in to fix the responses and fix the events to things that are within your control and within your policy. And getting back into interviewing stakeholders, I gave a talk at the beginning of the series about the NSA-IAM approach. That's the National Security Agency's information assessment methodology. It is a great methodology to use for interviewing stakeholders, and I would encourage everybody to leverage it to the degree that you can, because you need to ask probing questions. You need to go in with some plans around what the system boundaries are and get your stakeholders to identify what those systems are and the CIA values, and that's a very interactive method to do that. This will allow you to identify and organize your other requirements to physical versus logical. I'll probably close with that. And make sure as you're writing the verbs or actions, you use verbs or actions to write the requirements. So the system must do X. And then validate those requirements again against what you've learned and what you've gathered and what you've seen historically. Just a quick word on physical versus logical requirements. When you create the requirements, you want to separate them out into logical. Logical defines the what of a system or solution. So it defines what must be done regardless of the physical means to accomplish the goal of the task. So must alert in the event of malware answers the question what. A physical requirement defines the means that must be used in accomplishing those logical requirements, and that's kind of the how. So the virus alert must have the host name, IP, severity, and CVE tag answers how you're going to do it, and it provides a frequency, a volume, or other quantity or parameter by which to implement your goal. And that's pretty much requirements in a nutshell. Joe,
Wow,
back to you.
that's pretty good structure there, Mark. And I hope everybody appreciates that because that's what you just laid out. Even with the metrics last week, you laid out a structure for people to follow, and that's important. Very good job. And we will not see you next week. I'll be down at the National Conference and G1st Conference, National Business Meeting and G1st Conference. All right, so I look forward to seeing you the following Tuesday. Okay.
Absolutely, Joe.
All right.
Thanks.
Thanks, Mark. Appreciate it.